In this video, I'm going to explain network effects and demand-side economies of scale. Because in an age of social media, in an age of these big tech monopolies, this is really the biggest economic thing that we're having to deal with as economists. So first, what is a network? And a network is just a system that connects different nodes, where nodes are usually people, but they can also be companies or organizations or families. And the network itself is the system of connections between those. So let's depict that. Okay, that's a network. The two things that I think are important to understand about a network are, why is this a demand-side economies of scale situation? And second, why is there exponential growth and exponential value associated with a network? So let me explain each of these. Now let's start with the classic supply-side economies of scale, which is the one you might have learned in an Economics 101 sort of class. And this is basically where the source of value for a company to get bigger and bigger and bigger has to do with the inputs. It has to do with the fact that if you spread costs of production across a bigger scale of production, then the costs of paying your accountants and paying your engineers and paying for the training of workers to create a railroad, all of those costs can be spread across a larger number of products, therefore reducing the cost. So from supply-side economies of scale, we get natural monopolies. We get situations where it's just more efficient to produce when your company is bigger, so companies get bigger, and once you are that big, you can engage in predatory pricing if you see another company trying to enter the market. And in that way, you keep the market out. But what makes that a supply-side economies of scale situation is the efficiency advantage in that situation. The reason it's good to be big has to do with inputs and spreading those input costs out. With demand-side economies of scale, you have a different situation. It has to do with who is demanding the product. Because with networks, the value of the product has to do with the connections that are created across the many different nodes of the network. So each person, when they say, do I want to buy the product or go online or whatever, or engage in the network, that depends on how many other nodes they can connect to in the network. So ownership of the network itself is the valuable thing. It's not about the inputs, it's about who is demanding the product. And the reason it's good to be big is because the bigger you are, the more access each node has to the many other nodes on the network. So control over who's demanding your product is your source of power. And the classic example of the supply-side economies of scale is the railroads of the past, where it just makes more sense for one big company to produce all of the rails rather than having a bunch of companies producing rails that are sort of competing but running along the same lines. So that's an example of supply-side economies of scale where the control over that input, that laying of the tracks for the railroads, is the important thing. Demand-side economies of scale, obviously this is going to relate to social media, because on social media you want access to all of your friends and all of the people in your high school that you want to spy on. All of that stuff is associated with social media. So you want access to the people who are demanding the product rather than to the stuff produced by the product. Now, I will also argue that for any network that involves artificial intelligence, you're also going to have a strong supply-side economies of scale element. And that specifically has to do with data. Like, the bigger your network, the more data you have. And data is the key input into making your system better, making it work better, making the algorithms suggest better matches for you, all of that kind of stuff. So really for social media, I think both of these are at play, demand side and supply side, but the network effects principle really has a lot to do with demand side economies of scale. Now let's get to this second principle here, which is, why is there an exponential value associated with network effects? And I want to say this is not necessarily a good thing. As a matter of fact, this is the source of monopoly power that we're seeing in a lot of these tech monopolies, because even if a group of young maverick programmers comes along and produces an actual better quality product that treats people's privacy better, that gets around some of these problems in social media, even if they do that, it's going to be really hard for them to enter the market because they're just not far up enough on that exponential growth to actually add value, to have enough people using their system to compete effectively. Back to exponential growth though. So exponential growth is where sort of the value added by the network, which is of course what you're demanding when you decide to spend time on social media, versus the number of users on the platform is going to look like this. So the way to think about this exponential growth is to start with a two-person network and to say, okay, there's this unit of value that is sort of the relationship between these two. So we have two people and there's one relationship. If we add a third person, how many relationships do we have? We have one relationship here, two relationships, three relationships. If we add a fourth person to the network, we've got 1, 2, 3, 4, 5, 6. We've got 6. Now, one other thing I want to point out here is that one-on-one relationships are not necessarily all that matters. In fact, sometimes you enjoy having friendships in groups of 3. So like, there's a group of 3, there's a group of 3, there's a group of 3, there's a group of 3. Well, now it's messy, but if I add those 4 extra groups of 3, this goes from 6 to 10. And if I add the whole group of 4 that could have relationships, that gets to 11. And you could actually do this on and on and on. I'm not even saying I've completely exhausted that, but you can see if you count not only one-on-one relationships, but groups of 3 that might be really cool to get together, then for every node you add, for every additional node, the number of possible combinations of relationships and connections you could make goes up absolutely exponentially. And that's why we get this, this shape of the value of a network versus the number of people involved. Now, I would like to do a quick comparison of supply-side and demand-side economies of scale, because I think that highlights how network effects work pretty well. And these network effect companies can keep competitors out because they have this really high value based on how many users have decided to use Facebook and YouTube and all that stuff. So if a new competitor comes in, even if they have a better product, the fact that they don't have the number of people using means it's really hard to get people to use when their options are really high value Facebook and Instagram and all that, versus a better product but fewer people that you get access to, which also means less content, less stuff to interact with. So it's just really hard for competitors to climb this shape diagram. And that means they have this power. Like, because it's so hard for competitors to enter, they can use the power to do other things, which might involve selling your data, privacy violations, setting rules for governance of this group that the population doesn't necessarily like. So there's a lot that goes along with the power of being up here versus down there. And that is the essence of network effects.